Good afternoon, everyone. I trust that you had some refreshment and you got to do the assignment, the lunchtime tutorials. We are now ready to begin. Our presenters will be the same as this morning, Mr. Devani Lime and Mrs. Tamika Lodge Fenton. In addition, at the end of the session, we will ask you to do the tutorial for this afternoon session as well. And remember that this is both presentations this morning, this afternoon will be the afternoon is being streamed live on YouTube, and the other 2 days, all of them together are on YouTube. So you can go back and look through the tutorial, share with your friends, like, subscribe. It's now over to our presenters for the afternoon, Mr. Lime and Mrs. Lodge Fenton. Have a good one.
Thank you, Mrs. Darby. Mr. Lime?
Yes, I'm ready.
You can begin.
We're not hearing any talking.
Okay. So the first question we're looking at. Look at the cuboid shown in figure 7. Suppose we wish to find the length, y, of the diagonal of this cuboid. This is the bold line that you can see in the diagram. Note that ABC is a right angle triangle with a right angle at C. Note also that ACD is a right angle triangle with hypotenuse AC. So let AC have length X as shown. So all the information is given there. What is the length of AC? And I know someone can just easily walk us through this because we would have fully understood the Pythagorean theorem and been able to explain. So just open your mics, anyone, or as usual, you have the option to type in the chat. Tell me how you'd find the length of AC.
But before that, let's give them the easier, the easier one. In that sense, the length of BC. We all should be able to look at that diagram and be able to actually find the length of BC. And then we can move on to the length of AC. So BC, you can type in the chat, or you can literally turn on your microphone and speak to us. So the length of BC, then we'll do AC after.
So you just ask them to identify the information?
Yeah.
All right.
Anything no one in the chat?
I think we moved a little bit further than we needed to. Look at it. Look at the diagram.
Oh. Ooh. Okay.
So I just really want you to tell me how we find the answer. Let's see the chat. So first, just identify the value for BC. What is the length? So it's a question. What is the length of BC?
Miss 12.
12 it is. Now, when a unit isn't given, you're going to always want to attach a unit of measure. So since there is no specific unit given, we can just say 12 units. Okay, thank you. Now, as you can see, there is a value given for x, which is 5. But I wanted to tell me how you would come up with the 5.
Yes, miss, after working it out, I realized that the answer was weird.
Okay. So what would you get?
Miss, by the
It's okay. The noise is fine.
Mr. Our work it out, miss.
Yes, Michelle. Just go ahead.
And so c squared is equal to a squared plus b squared. C squared is equal to 4 squared plus 3 squared. C
Okay.
squared is equal to 16 plus 9. So you get
Mhm.
25. So c squared is equal to 25. Then you
Yes.
square both sides. And then
You find the square root
equal
of both
to
sides.
5.
Square root. Tishal, remember it's the square root of both sides, not square both sides. Finding the root of both sides.
Square root both sides. And then
Right.
equal 5 units.
Excellent job. Great job, Tishal. All right. Is that okay, Mr. Leamy?
Yes, it is. Yes, it is.
All right,
Sorry.
great. So from this, there's a lot of information.
This is judgmental. Just one quick one.
Sure.
Just to be precise, as good math students with 6 principles as practice to attend to precision.
Mm-hmm.
Since our diagram has an x, I would encourage her to say 3 squared plus 4 squared equal x squared, because her diagram doesn't have a c in it. So just to ensure she's using what is in her diagram, just encourage students to use what they see in their diagram to apply to the formula that they're using. So for example, this would say 3 squared plus 4 squared equal x squared for the diagram we have. Just a little detail to be keen on.
Brilliantly said, Carol.
Yes.
I mean, Miss Harris. Tishal, you get that, right?
Yes.
Okay, and everyone else on the platform. Yes. So when you do, when there's a value for the hypotenuse, you can use the unknown and fit it into and substitute it into your original formula for Pythagoras theorem. Continue, sir. Is there anything else on
oh yeah, there's one more thing. How about the length of
why?
The length of AB, which is y.
Okay.
That's the next one.
Okay.
So they would have seen that the AC would be 5 really and truly.
Right.
And they use the Pythagoras theorem to use that to the sum of the squares of the shorter sides, which would be 3 and 4. You square those, and then you can find the square root of that addition of the square of the shorter sides.
Right.
And the BC is literally on the paper, as you can see, which is just 12 units, right?
Right.
So we want to find the other unknown in this diagram, which would be the letter Y, and it's indicated by the length of AB. How would you go about solving for AB?
The question is, we would have presented you with 2 scenarios in the morning session. Are these 2 questions, finding X and Y, are they the same scenario or are they different?
Different.
Explain.
Mr. P.
The method you use to find X, would you have to use a different method? Is the scenario the same? Are you finding the same side or not?
Yes, Miss, the same.
So would it be the same scenario that you're looking at? When you found X, what side were you finding?
The hypotenuse.
Hypotenuse. Good. If you're trying to find Y, what side would you be finding?
The hypotenuse.
So that means you have 2 sides. You have the 2 shorter legs, right? For X, you would have 3 and 4. For AB, which is Y, you now have 12 that was given. And what is X? X is now what? 5. So you still have the 2 shorter sides finding the hypotenuse. So the scenario is the same. You have the 2 shorter legs, and you're going to add to find the hypotenuse, right?
And remember, you can always sketch that diagram, that right angle triangle, in order to find the value of the length of AB, right? So you can use the triangle ABC in a nutshell. So let's see if they can actually draw that triangle, and then we need to find the hypotenuse. So just draw that little sketch of that diagram, triangle ABC, and then we can proceed afterwards. And remember, yeah.
Put in the dimensions, guys. Draw ABC and put in the dimensions. And just open your camera and show us. Whomever can.
And remember, the Pythagoras theorem is it's only used when you have a right angle in that triangle. So in that case, that's why we can use the Pythagoras theorem in this one to find the hypotenuse, which is the length of AB, or the side Y, unknown.
Okay, to show the dimensions are the lengths of the sides. So when somebody talks about the dimension, when you hear about the word 3D, it's a figure that has 3 dimensions. It has height, width, and what's the other one? Length. It has 3 measurements. So you probably have
length, width, and height, or depth.
Thank you. So the dimensions that we're talking about, Shell, is the 3 sides. It has 3 sides, and I want you to give me the 3 measurement. Well, one of the measurement will be Y, and you can give me the other 2, because it's a triangle. Nothing fancy, just something quick, and to let me know that you're out there and you're working and you're thinking.
Could you zoom in a bit more for me, Tashel? Can't really make it out like that. Mrs. Lodge Fenton, are you seeing that? I'm literally like really up and close to the camera right now.
Tasha perhaps need to give us some light in her background. It's a little dark.
Yes, it is.
Oh, geez, I'm here talking and nobody not hearing me. Tasha, I was asking you to put it back on the book. I'm so sorry. There you go. So you have labeled it A, B, C. Great. I love the fact that you remembered your right angle, and you have 12 units on that side. That's the one of the dimension. And no, maybe I should not have used the term dimension then to look at it now. That's one of the sides. Let's use the word sides. Teshel, you brought something to my attention right there. So it has one of the sides is 12 units. One of the other side is 5 units, and the other side you have labeled Y. Excellent. And you've gone further. Continue, keep your book so I can see. So you've worked out Y squared equal 12 squared plus 5 squared. It's a bit frozen, I can't see anything. Is it me or is it frozen for everyone?
It seems like it's frozen now.
Okay, but I saw you started to work it out, and if you continue with the correct calculations, you should be right on target, Ashel. So you should have the square of 12 being 144 units, square of 5 being 25 units, and the sum of those two will be what? 144 and 25, that will be 167. No, 4 and 5, not 7.
You want me to
That's
proceed?
like 9.
other slide?
Yes, continue, sure.
Yes, I
You want
think the other slide.
169. Thank you so much, Michelle.
All right, so this is our little sketch.
Right, go ahead.
And we label the sides, and you notice this arrow opposite to this arrow opposite to the right angle, and this side would be the hypotenuse, right? And we have the two shorter sides, which would be 5 and 12. So we need to actually square those two values, and then we add those two together. So let me just...
So the
Yeah.
two shorter sides, 5 and 12, would be the dimensions that we are looking for. So we put the dimensions on, you have put your dimensions on the diagram. The unit of measure could also be there as well, but the dimensions mean the side. So we do have the dimensions on this diagram that we have taken out of the larger diagram.
All right. So we go back to our traditional formula or equation for the Pythagoras theorem, which would be the sum of the square of the two shorter sides, which would be a squared added to b squared is equal to c squared, and c would be our hypotenuse. In other words, our y value, once we substitute or plug in our values that we have on that little triangle that we had, that little right angle triangle that we have on the right-hand side of the screen. So we use our a value as 12 and our b value as 5, then we square those values. As I think Tashel had written in her book, so we said 12 squared. Could you repeat that one? Okay. All right, so that's 12 squared added to 5 squared equal to y squared. And y now being our actual hypotenuse value that we need to find. Not y squared, but y. And remember the use of your calculator. Once you need to input the correct values into your calculator in order to get or deemed to be a correct answer, or answer that we think or we know that is actually correct. So 12 squared, the timetable table times, which is 144, and 5 squared, which is 5 times 5, which is 25, is equal to y squared. That should be y squared, not c squared, because we already substituted the value of the hypotenuse to be y, which you want to find, or the length of AB. And as Tashel, had indicated, 144 added to 25 is 169. And then we can find our y value, not c value. Again, apologies for that one. So we square root both sides. So the square root of 169 is, what's the square root of 169? Can anyone tell me?
I think it's 13.
Okay, 13. Okay, good. And remember now that the units, we don't have like centimeter, millimeters, etc. So we just write 13 units. And again, apologies for the C. It should be Y because that's the actual value that we're finding. So Y, or the length of AB, is equal to 13 units. Okay? Everyone is okay so far with that? Everyone got that right in the little tutorial session? Well, the tutorial sheets that everyone received? Did anyone get that right besides Tashel? Anyone else got that right? Okay. Okay, Chanel, good, Chanel. All right. Anyone else? Anyone else? Nope. All right. All right. Mrs. Lodge Fenton, can we continue?
Most definitely, sure.
Right. So now these are somewhat various or a variety of ways that we can actually see a Pythagoras question. It might get a bit more challenging than this. This is somewhat a little bit harder than what we were doing earlier in the earlier session, going on to the last part of the morning session. So we have A, which is on the left side, which is the multiple triangles chained together and you see a little example of that. Then you see B, when you're adding lines to form right angle triangles that weren't there, right? So you literally, for the first one that you see, that equilateral triangle that you see, and you see the area in the middle, we're gonna actually add lines or use lines, or in other words, we bisect it, and then we'll be able to solve for any unknown sides in that regard for the height, if you wanted the height. Likewise for the other triangle in the middle. And finally, we have C, which is requiring some form of algebraic manipulation. In other words, algebra is somewhat a weak topic for us. So we'll be doing a few of those algebraic manipulation or algebraic expressions in the Pythagoras theorem. All right, Mrs. Lodge Fenton, you can take that one.
Yeah. All right. All right, so here we have multiple triangles. Sorry. What should we do first? So we have a triangle. We can call this a compound shape. It's two triangles come together to give you a bigger triangle. And the important things here, we want to make sure that we have right angles within the triangle in order to apply the concept of Pythagorean theorem. All right, so what should we find first? What should we do first? All right, so we see that X is there. Can we find X right away?
No, miss, you have to find this. You have to find the hypotenuse. You have to find the opposite for E first.
You know me, I have things that are opposite there.
Miss.
Yes. You see the angle in there? Show me the angle that you use.
Miss, it's because like I'm so used to calling it opposite and hypotenuse.
All right. But the opposite can change, because if we have an angle at the top of the triangle, the opposite is where 4 is. And if we have an angle over by the corner to the darker point, I can't even use a pointer, you would have, yes, go over to the darker point, the corner to the 4, the corner, yeah, okay, right there. If we have an angle
right,
there.
No, left corner, left or right corner, which corner?
Thank you very much, Hazel. The left corner. If we had an angle in the left corner, then put a line straight across. So this would be the opposite side to that angle. But if we had an angle up in the top, yes, that one right there, then the opposite changes. The opposite comes down. Right. So the opposite angle to the opposite side to that angle would be where that arrow is pointing. So you see that the opposite doesn't stay stationary. Yes, do you see that now?
Yes, miss.
And you can only refer to the opposite when you are talking about a triangle that has another angle in it outside of that 90, or an angle that they're referring to. So even if you were looking at the 90 angle, that would not be the opposite. And then you'd have a problem because you'd have two adjacent sides. So you can't use the word opposite unless I give you another angle in the triangle. So let's talk again now. So we can't find X. I agree with you. You are telling me why I can't find X. Tell me now. You want me to label the triangle?
Miss, could you put a Y
in the middle line?
Yes.
All right.
Because I don't. My mind doesn't
call it opposite.
Yes.
All right, not a problem. Sir, can you put in that Y for us, please?
A Y should be there. It will come up automatically once I drop this.
All right. So I agree with you. Is this Tashal talking? Who's this? Shay?
Shay.
Okay.
Shay, could you describe where I can find the thing, I'm going to call it, that you want to call Y? Is it a line you want to call Y? Is it an angle you want to call Y? What's the position of that line? Oh, I give it away. Is that line you want to call Y?
Yes, the one that I keep calling the opposite.
So tell me about that line. You were at the coordinate geometry class. What type of line is it? Which way it going?
It's going. Miss, I do not want to say something though.
No, it wouldn't be consenting, and we are here to correct you if it is not correct. It is your thought. Tell me the direction of that line that you're talking about. Is it going across?
No.
Then which way it going?
I believe it's going up.
You believe it's going up. Mr. Limi, could you label the line that is going up as Y and let us see if that is the one she's talking? Because the only line I see going up is that one that Mr. Limi is about to label. Is that the one you're talking, Shay?
Yes, that's the line.
Okay, so we can use our directional words to describe, since we're in a conversation, the line that is going up, the vertical line. All right. Maybe we could put some additional labels on it. What about labeling the corners?
Yes, I was just going to say that it would have been helpful if we had labeled the triangle, the bigger triangle.
And even the perpendicular line coming down. So we should label this so that Shay can talk to us and the rest can talk to us.
You want me to label it as ABC?
You're going to have to be labeled as A, B, C, D for that perpendicular. Oh, yeah.
You could make the base between the 3 and the 4 capital X to line with the common X on the other side.
You want me to put E right
Confusion.
here? Okay.
Big.
No, remember in trigonometry, angles are named with X. Oh, so because you have the Y over there.
Yes. Oh.
I don't think we should go there. No.
Yes.
Yeah, it's all right. Don't bother with the
conversation to get there. So I think it's regular.
Yes, Tamika?
Shay?
Oh.
Shay.
Yes, miss.
Because we're gonna highlight something to you. Put the B back. We are going to ask you to just look at what else we could label Y as. Put back the B. So conventionally, when you label a triangle, it helps you, when you label the angles of a triangle, we use capital letters. So you would have called this point A, and you see B, and you see C. Now those capital letters indicates that we're talking about the angles. Now, when we look at the angles, we're now able to label a triangle that someone else who is looking on won't make no mistake about it, because we use the angle, and the opposite side from the angle is denoted by a common letter of the same angle. So for instance, if we're looking at C, I know we have X there now, but what could that X be labeled as? It's a capital C over there.
Common C.
Excellent. So it could be called a common C. Now, if we're looking at A here, what else can we call Y? Common Y, you sure?
A common A.
Excellent.
A common A, sorry.
Right. So we could definitely use a common A to label. Thank you, Tatiana. To label the line the line segment that we would have labeled Y. Now, why is that important? It helps us to be consistent, not only in your math class, but in every math class in Jamaica and across the world when we're sharing information. For instance, if we were so advanced that we're doing exchange work or exchange school or homework cross or pen pal, whatever, when we talk to someone in another math class, they could easily follow the concept. Do we understand? Guys, you have to open the mic and talk to me. And I can't talk to myself. Good. Thank you, Tatiana. All right, so we're going to remove that Y and we're going to put common A. I know the X don't line up, but we're just going to allow it for now.
Miss?
Yes, dear?
So, Miss, why didn't label 6 as A?
Go ahead, talk up loud. I didn't hear that.
Miss, why didn't name the 6 letter A?
Oh, that's very good. So if we are looking at the triangle without that middle line, we could definitely label 6 letter A as well. You are correct. It could also be called letter A. However, if we are looking at, it depends on the triangle that you're looking at. If we're looking at the large triangle, we could label 6 letter A. But let's say we had, another letter here where the two right angles meet, where the vertical line right there, label the middle angle, the 90 degrees, label it, I don't know, X, capital X.
You want me to separate them, as in separate the triangle?
No, don't separate it. Put a big X right down there. Now, this is definitely a weird way of labeling the triangle, but let's say we had a big X there. Then we could explain why we have little X for the label over there. Everybody sees that?
Yes, Miss, but I don't understand.
Tell me what you don't understand.
Oh, my Lord. Why are there little A's and
All right.
Just a convention. Sorry, Mrs. Lodgefent. Remember yesterday, David, I remember your name from the previous classes. Remember we were talking about conventions in math, where it's a standard practice, a practice that is used generally worldwide, so that in mathematics, in geometry in particular, when you're naming triangles, you name angles with uppercase or capital letters, and you name the opposite side, the side that faces the angle, with the corresponding lowercase or common letter.
oh, wow.
Which is why it's just a convention in geometry. And since trigonometry kind of is like cousin to geometry like-ish, so you're gonna apply the same convention there. So even if you when you look at your formula sheet next time, you'll see that the triangle that they use for the formula sheet, it has A, B, and C, and the common A, B, and C. So next time you look at your formula sheet for CSEC, you may observe that, and it will come, oh, so that's why it's like that. So it's just a convention that is used. Yeah.
Thank you very much.
Is that better, David?
Yes, Miss, sure.
Good.
So you guys have been, thank you so much, Miss Harris. You guys have been seeing this for a while, but I guess your attention wasn't really drawn to it. But as Miss Harris says, it's a way in which we are able to communicate with others with very little confusion or with much clarity then. Okay? So if an X was in the middle right there by that perpendicular line, because as you can see, it's perpendicular to the base of the large triangle, giving you two smaller triangles. So that angle X would be for both 90 degrees on either side. You agree with me? So either side could be called what? Could be called X.
Right. Yeah.
Great.
Okay.
Great. All right. So that's just a little background information. So we did say that we'd solve for X first. It was Shay that was talking, because Shay said we needed to label the perpendicular line as A. Shay, you want to pick up for me?
Sure. Well, let me get my book because I kind of worked this out already. Okay, so first you have to, before you could find X, basically, you have to find what A is. So when I worked it out, I got that it was equal to 2.
Okay. How you did that? Just tell us.
I found the, hold on. I found the square root of 3 and 6. Then I transposed, and then I got 4, but then I wanted, I didn't want it to be b squared equal 4, so I squared it and I got 2.
Okay, so it would be 6 squared would have been what? 36?
Yes.
So 36 subtract how much? How many? Yeah, how many?
9.
9. Gives you what?
It gave me 27.
And what's the square root of
I
27?
heard
I
an
did
error
something
somewhere
wrong.
there
I did
because
something wrong.
she
Hold
didn't
on.
say she squared.
Yeah.
Oh,
Right.
oh.
Use scenario
Yes,
one.
Didn't
who loves
square.
that self-correcting?
She picked it up,
Oh.
man. She saw it because I said, I want
Hey, you go, Shay. Nothing like self-correction. And as
Good.
David said, the best place to make the mistake is in class, not on the exam.
That's good.
So you have to square first before you do the addition or subtraction.
Right. And as I said before, remember, whatever we learn in math, it integrates. So when you learned about pen mass,
Mean
pen
bomb
das, bomb das,
das. Jamaicans call it
Bamdas,
bomb das.
PEMDAS.
Yeah. PEMDAS is more
Oh.
American.
Mm.
So when you learn about bomb das, you must always remember that there's an order of operation. So you have to do what's inside that bracket first.
Square it first before you add
Sure,
or
before you
subtract.
add and subtract. Yeah.
Mhm.
You do your powers before your addition.
Where's she gone?
Okay.
Fixing her error. She's fixing her error. Remember, she said, oh, I did it the wrong way. So she's fixing her error. Unless one of her classmates wants to pick up and move with it.
Troy, nice to meet you, Troy. I see you have B being 4 equal B. And I'm assuming you're calling B the side that, oh, if you're using the label, B. What, Troy? Thanks. You said B equal 4. What side are you referring to as B? Oh, first time here. Well, it's a pleasure to have you, sir. I'm sorry you missed the other presentations, but we are on YouTube. You can definitely go and subscribe and watch them in your own time and share with your friends. So, Troy, what side are you calling B? Oh, you are at school face to face. I totally understand. Yes, I see that you're saying the value of B is 4 and you use a common B. Excellent. But which side would you be labeling? Oh, I see what you mean. Good job. So if you are calling that B, yes, you are correct. You are correct. So B can either be the 4 or the 3. Good job. Excellent. Yes, Shay, continue.
Okay. I realized my error was when I was transposing, and instead of getting 27, I don't know how I got 4, but I got 27 now.
Okay,
And
good.
I squared it, and I got
You squared
5.
it? You squared it?
Yes.
You sure? So you timed 27 by itself?
No.
What did
I
you
found
do?
the square root, sorry.
There you go.
I found the square root of 27, which was the square root of 27, which is 5.196.
Sounds pretty good right now. All right. So you'd have found the value for A, the length of the triangle represents A, right? Or yes. So now what do you do?
You substitute it in the triangle where A should be, and then you work to find X.
Okay, great. All right, let's see what is under those as the thing is.
Oh, okay. I was just gonna write it and then see what she said.
See. Okay.
All right, cool.
Yes, what number is it?
Go ahead. I didn't hear the question.
Yes, what number is that? That's A. I think you just wrote it.
Oh, 5.19?
Yeah, 5.1. Well, you can run it out to 5.2.
Mm-hmm.
Yeah.
One
Because
decimal.
yeah. Because it's
Or
5.9.
just leave it as root 27 since you're gonna use it again, just like we learned this morning.
Look, that can work too. Or you can leave it at root 27. So you could write your square root sign and just drop that 27 in it.
Thanks.
There's the Y.
By using triangle E. And of course, we would have known that the y is the same that we were calling a. All right. So excellent deduction, guys. We're just going to go through how we would have found it. We always refer to our original formula of the relationship that exists within right triangles, where it's a squared plus b squared equals c squared, where c is the hypotenuse. Go ahead. All right, we subbed our values in. And we would simplify the equation as best as possible. So we'd have found, okay, great. There you go. So as I said to you before, you can work out 6 squared and then subtract the actual value of 3 squared, or you can put that in a bracket because you'd work out what's in the bracket first, and then you would use your square root sign. You can do that. You work out what's in the bracket, give you 27 units, and then you would be expected to find the square root of the 27. And you can keep it in that form and put it into your diagram in order to work out the other. So let's continue.
Sorry for the bad handwriting. Yeah.
That's fine. It's perfect. We can see it.
So then what do we need to find next? What is the next thing that we need to find?
X.
Who said X? Who said X? I can't see her here. Oh. All right. So then we need to find X. So we're using that triangle F, that small triangle over here, which is F. And then before we were using triangle E over here to find the value of the Y. So we do the same thing that we did originally. We have our formula in general for the Pythagoras theorem. So that's a squared plus b squared is equal to c squared. Again, a squared added to b squared is the sum of the square of the two shorter sides of this triangle F that we're concentrating on. Not the big triangle, but we're somewhat putting it into two pieces. So we're concentrating on triangle F. So now we get 4 squared added to the square root of 27 all squared, right? And that's equal to x squared. X now being our hypotenuse that we substituted that value. Instead of having c now, we have our hypotenuse that we need to find, which is indeed x. And then we continue. We see that using the root 27 or the square root of 27, we square that and we get 27. So that's 16, which came from 4 squared. 16 plus 27 is equal to the hypotenuse squared. Remember that we actually want to find the value of x, not x squared, but x. And someone is saying something in the chat. Okay. David, what is 6.56? Could you tell me that one, please? What's 6.56? What's that one for David?
Yeah, or 6.6. Like when you round it up.
Cool.
But yeah. Okay.
All right. So how many decimal places? How many decimal places do you use for that one, David?
Wait. Like for the hypotenuse, you should always
for the x that we found, the x that you found, the 6.56. How much decimal places did you use?
I used 2.
All right, and you notice that Tashel used
1,
right? Or if you want to say 2 significant figures and 3 significant figures, whichever suits you best. And yes, that's correct. And remember, David, that you need to have your units, right? Once they never stated a unit, centimeter, millimeter, etc., we tend to use the word units. Okay?
Wow.
All right, good. Yeah. All right. So notice that everyone got the calculation. You're using a calculator correctly. And you got 6.6 units rounded up to 1 decimal place, or 6.56 to 2 decimal places, right? But now,
Mr. Lima, may I chime in here?
Sure.
Let's go back to the first triangle where you find y. Remember that on the multiple choice, you are not allowed a calculator So you might see an answer like root 27 as one of the options because you're not allowed a calculator and you wouldn't know the square root of 27 out,
Right.
you know, in your head just like that. In addition to that, they might think that you can estimate what the length would be. So right now when we are doing X, it is, when we add that, we get what? 43, sorry. 43? Yes, 43. Okay. So the answer, if it were a multiple choice question, it might come up as the root of 43, the square root of 43, because you are not allowed a calculator in the exam. The examiner might take it a little further and say you must be able to estimate what is the square root of 43. Should it be about 4, about 5, about 6, about 7, something like that. So if you see some answers coming up for the square root of 43, for example, 6.56, you might ask, why would I think I would know that the square root of 43 is 6.56? Can anybody answer that? How could you make a reasonable estimate of where the square root of 43 would fall? Would it be about 4? Would it be between 4 and 5, 5 and 6, 6 and 7, or greater than 10? How could you know? What do you know about square numbers that could help you to say what the square root of 43 could be, about how much? Let me ask the question again.
Oh, wow.
Go ahead, Tania.
Miss, I said 6 times 6 is 36 and 7 squared is 49. You said with 42 are 7.
I love that explanation, Tennille. I want you to say it again. I hear you clearly, but I understand you clearly, but I didn't hear you clearly because you were a little muffled. Could you say it again? I like how it sounds. Go ahead again, Tashel.
Miss, 6 times 6 is 76 and 7 times 7 is 49. So it was 42 or close to 7.
Well said. So let me repeat what she said. She said that she knows that 6 squared is 36.
Good
and
job.
she knows that 7 squared is 49. So if you want to find the square root of 43, it would fall somewhere between 6 and 7.
There you
Again,
go.
it is more than 6 squared, but less than 7 squared. So therefore, the value must be somewhere. Wow, David, thank you for that. Thanks, Tashel. David is congratulating you.
David.
All right, take it back, presenters.
Go ahead, Limi.
And one of the things that you can also use is that your square numbers, your perfect squares, right? So you might see an answer saying, okay, that square root of 43 units, it may be between 6 and 7. Because if you square 6, you're gonna get 36. And if you square 7, you're gonna get 49, right? So that value is actually between the square root of 43 would be somewhat between the square root of 36 and the square root of 49, which would be 6 and 7 respectively, once you square both sides, or get rid of the square root by squaring the thing, right? So that's one of the things you should look at too. Perfect squares.
Okay. Okay. All right, before you move on to the next slide, we'll just go back once. So remember, we keep on talking about the 2 scenarios that you will be presented with. Is it one scenario we're seeing here or both? Remember one scenario? Huh?
Miss one.
Okay, tell me the one that you're seeing. So are you given the shorter legs, asked to find the hypotenuse for both cases?
Oh, we 2 of them.
Okay, good. I want you to be able to look at whatever diagram you're given and realize what is being asked of you. So the first, the triangle E, you're given the hypotenuse and one of the shorter legs, and you're asked to find the other short leg. And then for triangle F, you would have determined what y value is, and then you would have been asked to find the value of the hypotenuse. So both scenarios are presented here. Okay, go ahead, Limi.
Michelle, you had something else you wanted to say?
Yes,
Or you're okay now?
Yes, I have a question.
Go ahead.
Miss said like for the paper one, that we would get the exact answer because we don't have a calculator. So would the option be square 23? Alright, then I go put in decimal or something like that.
The answer might be left as root 43, for example. That might be an answer if they were trying to find x as in the scenario here. So they might leave it with the square root sign on it. Or just as you said in the earlier explanation, they might give it the answer. What was it? 6.6, sorry. And some other answers. And you would have to reason like what you did correctly a while ago to say the answer should lie between 6 and 7. So sometimes they leave it with the square root symbol, and sometimes they give you some actual values, and you would have to surmise, think about it, and decide which is the best answer based on your knowledge of square root. Does that answer your question, Tashel?
Yes, thank you.
Okay, you're welcome. Take it away, presenters. Over to you, presenters.
All right, so this one now, we're actually going to add some lines to this. As you can see, that's this line right here. Let me annotate it a bit. This line that you see right here, it wasn't in our original diagram, but we added this line in order to form somewhat of a right angle so we can actually see it. It's to make it more obvious in our eyes, right? And you notice again, we have two smaller triangles in that larger triangle. So we have triangle B and triangle D. Once they come together, they actually form that compound shape that you see on the screen right now. Okay, let me get rid of that. All right, so again, somewhat the same procedure as before. Which one of these letters would we find first? Would we find X first or would we find Y? And why?
I'll find with me.
And because we get to know hang off.
Why
Yes.
I would find why, because I mean the formula says what a squared plus b squared gives a c, and yeah, and I think a squared is a squared the base or the opposite one? I think
Hold on, let's ask Tashel. Is a square the base?
Using triangle D.
Or Shay?
Miss
Anybody? Oh, Dave, was that?
Or David.
okay, so a squared, I think a squared is the base and b squared would be the opposite side.
So we couldn't call 7 a squared?
Sure.
Oh, so it doesn't matter. The 4 or the 7. We can use any one of them for A.
I understand. Okay, cool. Yeah. So
There's only one side that we can't change. What side is that?
That's the hypotenuse.
Good.
That's
And how you identify it, David? How you identify the hypotenuse? The hypotenuse.
It is all right. It is the opposite. It's opposite from the right angle. No.
There you go. Listen, David.
Oh,
the confidence itself.
Okay, thanks.
Good. It is the opposite from the right angle. Good job, David. Continue now. I'm going.
David, do you want to continue? Oh, right. Yes. So, so a squared plus b squared equals c. So you have to find a squared and b squared first in order to find c squared, and then yes. So that's why. So like this, right, David? Yes, sir. Sure. All right.
So again, a squared plus b squared is equal to c squared, where c is a hypotenuse. And the hypotenuse, what would the hypotenuse for triangle D be? What would the hypotenuse be? What letter? And is that hypotenuse the same thing for triangle B? Is that letter the same or is it different?
No, it is the same, sir.
All right. So again, the opposite side to the right angle is called the hypotenuse, right? All right, so
Yes,
our
sir.
values of A and B. Could you repeat, Tasha?
She said, yes, sir.
Okay. So we got 7 squared added to 4 squared. And as Mrs. Lodge Fenton said, it doesn't matter which of the sides are labeled, as in which one of them are A or B in this sense, because we don't have any angle being measured in order to denote certain aspects of that special sides of the triangle, right?
Right.
So 7 squared added to 4 squared. Can anybody tell me that value right there? What is 7 squared added to 4 squared? The sum of the square of the 2 shorter sides is equal to the hypotenuse squared. What's 7 squared added to 4 squared? Chat. Okay. Yes, Tasha? Is it Tasha? Yeah, Tasha.
It's 65.
All right. Okay.
Good job.
Let's see if it's 65. But I'm doing more work right here.
Mm-hmm.
So it is indeed 65, right?
Michelle, you're right. Yes.
Right. But remember now that we're finding the value of y and not y squared. So this is why you see that square root sign before the 65, right? So can somebody tell me what is the square root of 65?
That'll be 8 units.
To the nearest. Well, not to the nearest. Okay, give me to the nearest, the whole number.
I was wondering if they could estimate before they use the calculator.
Oh.
Oh, that makes sense. Oh, wow.
So we know it's more than 7 because 7 is 49.
Yeah.
What is 8?
64. All right.
Ah.
And that is very, very close to 64. That's 65, right?
So we know it's 8
Right.
something.
Right.
There's only one over there.
Mm-hmm. Yeah, 1 over, which is quite a lot. Well, no, it's not quite a lot. It's quite small, I would say.
Right.
All right.
So-
And the answers in the chat. Okay. David and Shay said 8.1.
Units.
Remember, Shay, you should have units.
David,
That's quite important.
good job, David.
So we could say it would be very close to 8. Very
Yeah.
close to 8, and 8.1 is close to 8. All right.
Ignore David's answer.
Jason was ignoring David's answer.
Now we're getting boastful.
Yeah.
Confidence turn up.
That's right. I'm
And-
loving it.
And even if you actually do physics too, another subject, C-Sec subject, this is quite important where units are quite important when you're actually transposing and balancing off equations and all of that. So that's important. The unit is quite important once you're doing mathematics and even physics, right? And even chemistry if you want to chime in like that. So we have the y or the hypotenuse to be the square root of 65 units, right? So I'm just gonna write that square root of 65 right where I want to turn. So I have that, right? So that's my hypotenuse for both. Is it for both triangles B and D, or is it just for one of them? I think David had highlighted it earlier.
I was just going to say that David did tell us
David
already.
highlighted it earlier. Okay, it's both of them, right? So the next thing that we need to find, we solved one part of it already, which was y. Then we need to find the other unknown, which is x, right? So what's the procedure for this one now? In other words, what do I
Yeah, how we find X?
Yeah, how would I find x? Would I use scenario 1, scenario 2, all of that comes in? Would I add, would I subtract?
Scenario what? Who's that?
Subtract.
Okay. All right.
You would be subtracting. Very good. So you would definitely be subtracting to show. Go ahead, sir.
All right. So what would we start with, Tichelle? What would we start with traditionally? What would we start with traditionally? Tashel, or anyone wants to help? Could you repeat that one, Tashel?
X squared equal B squared minus A squared.
Oh, so you substituted everything already?
Girl, just going straight ahead. Look at you.
I finished it.
All right. So we have again on the right side of the screen. Huh?
But hold on.
Confidence.
Yes.
Yeah.
So we always want to start with our initial relationship. A squared plus B squared equals C squared. Then we're going to sub. Why we are encouraging to start this way. You have your reference point to check back. It's like when it was Shay that was checking and she saw her error, she could have just easily corrected herself. So your reference point help you to make sure you're going along the right path when you start with your initial relationship.
And even with something like this, they want to see somewhat the steps that you use. So if you made a mistake, let's say this was valued at maybe 3 marks, and you made a mistake somewhere, and then you could have gotten, instead of getting full marks, you got 2 and 2.5 or even 2 marks out of the 3. So this is why you need to check over your work once you finish working, and then you continue using the steps that we have right here. So it's A squared plus B squared is equal to C squared, and that is the sum of the square of the 2 shorter sides, which would be A and B, and then it's equal to the hypotenuse squared, right? Tashel, could you continue for me, please? What would I write next? Or anyone who wants to chime in? Anyone? You can speak.
Okay, so here we are, and I know all my hardworking students are pretty sure where we're going with this because they're right. They're so on target. Right, Michelle? And David? Good. So we're now going to find x.
X.
And x is one of our short sides. So we have the hypotenuse, which is y, which we found to be the square root of 65 units. And we can just pretty much sub stuff into the original formula. Now, we're using a as 1. And clearly, x is going to be b. So we put x in the equation right there. And we work out what can be worked out. And we sub until we get down. So here we go. 1 squared is what, guys? What is 1 squared?
1.
Exactly. 1 squared is 1. So 1 squared, 1, we subtract that. And that would have been leaving us with x squared. And 65 subtract 1 gives us 64. And now we have x squared equals 64. The square root of x squared.
Is that 7.1? No.
David.
Is it? I'm not sure.
Ah, you just told me 8 is what?
Oh my Lord. Oh, I'm so dumb.
Oh my God.
I can't believe it. 64, man. Yeah, you said 64.
That's $8. Oh my.
But I'm happy that you're pushing yourself to estimate it. But you must pay attention to the square numbers. Right. So right. But I'm glad that you're now getting to the point where when you see a square root of a value, you are attempting to estimate it without plugging it into a calculator. And that's excellent. Okay. So the value of x is 8 units. And that would have been how we would have found the 2 values for those 2 lengths that are unknown in this particular compound shape. All right.
Oh, one more thing. And if you notice, if anyone noticed, if this is 8, and this, we said the square root of 65 was about 8.1.
Yes.
So if you look at it, the hypotenuse is the longest side for this, for either of the triangles, right? It's greater than 7 and it's greater than 4 in triangle D. And you look on the next side, triangle B, it's greater. Even if it's really, you see the difference, it's 0.1, it's still greater. So no matter how small the difference is, it still matters. The small things really do matter in this case, especially units. Well, let's continue.
So it still has to be the longest side because that's what we claim. We claim that the hypotenuse is the longest side. Okay. Go ahead. Algebraic triangles. Go ahead.
Let's see what's in this box.
Look at that. All right. What do you think they're going to ask us to find, guys?
Miss A.
Hey, tell us what you're going to do. I'm not even going to say anything.
But
What will
why-
you do there?
But no, why would we solve for A? Why not something else? Why A? Why A of everything else?
I don't know. I mean, like it's a variable. It's there.
Huh? It's
I
a
was saying-
variable. I mean,
Yeah.
what else can we say about that? What do you normally hear about when you see variables? What do they normally classify that as? In layman's terms.
In multiplied by the number
Okay, what else? What is A?
that
If
it
I-
represents a number.
Okay. I'll cut it as the unknown. It's like an unknown side. Even if it's 4 multiplied by A, we don't know what A is. We need to find the actual number, right? And
Right.
3A, 3 multiplied by A, right? So we
Yes.
need to find that unknown variable, which is A. All right? And someone said in the chat, okay. All right, cool. So it's the same procedure for this one. Again, we have our emphasis on what we should start with, which is our Pythagoras theorem. And can somebody remind me why are we still using this Pythagoras theorem? Why for this shape or this triangle? Why are we actually using Pythagoras? Why are we not using something else, something more complicated, I would say? Why? Anybody tell me?
I'm not sure. I think you said earlier because it's a right angle triangle.
Yes, it is. So that's the emphasis is on the right angle, right? All right, so A squared, so thanks much, David. So A squared plus B squared, the sum of the square of the shorter sides, is equal to C squared, which is, again, I think we're getting tired of saying this, but we need to have emphasis on that. So C is the hypotenuse. So what would the value of C be in this triangle, in this right angle triangle? What would the value of C be?
C here. What value represents C?
Yes, sorry, thanks. You can type in the chat.
They can talk. They
Yeah,
can talk.
How about this one?
15.
Right,
15, okay.
15. Good.
And the shorter sides, can you tell me the letters, well, the variables that would signify the shorter sides?
A squared and B squared?
As in the variables in the
4
triangle.
and 3.
Oh,
Four and what? Could you repeat that one?
3.
So what
Is it just 3?
4A and 3A.
All right, fantastic. So we're gonna square the two shorter sides, right? And it's equal to the C squared, which is 15. So we did just like that. So now we have 3A squared. You can't type in, you can't even plug that in your calculator. So you have to somewhat, I won't say street smart, but you have to use
Tell me,
something
sir.
else, break it down. You have to break it down. In that sense, I'm gonna put a note over here. So it's 3A squared, sorry for that, is basically 3A.
Square, guys. Don't tell that. What can I do to 3A squared to get rid of the square?
Oh, you're doing that.
I guess you can just distribute. No.
No, she's asking
Why
how
we
would you
getting
get
rid
rid
of the
of.
square, Mrs. Lodge Fenton?
I think she's just puzzling them or trying to do something. I don't know.
Why are you getting rid of the square?
Because I kind of not with it like this, miss. What am I going to do now? I don't know.
But we're just simplifying the expression on the left side, miss.
Yeah, but I can't simplify it anymore.
You sure?
I don't.
You sure?
All right, go ahead.
So let's do this one. So 3A, 3. So 3a is in the brackets and it's squared. That means whatever is in the bracket, you're going to multiply it by itself, right? So 3a multiplied by 3a. So some persons might actually multiply the letters, well, the numbers first. So what is 3 multiplied by 3?
9.
9. And then we say a multiplied by a, laws of indices now.
A squared.
A squared. Right. Fantastic. So this is 1, a to the 1 and a to the 1. And remember, laws of indices, when you're multiplying by the common basis, which in this terms is a, you add the powers. So that's why you can add 1 and 1 to get the a squared. So this right here is equal to 9a squared. Oh, let me not write that. What would the next one be? 4a all squared.
It would be 16a.
No, it would be, it's gonna come on the animation. So I don't need to write it.
That's why you're saying that, yeah.
Yes. All right. So that's 16a squared, right?
Yes, sir.
And it's equal to 15 squared. What's 15 squared? 15 multiplied by 15. No, you can use your calculator.
225.
225. So that's what we get right there. Now, I mean, what would we do now, right now? What should we do to find the value of a? We have a squared. What should I do now? What is there to do? Can anyone highlight that or tell me?
So you can say 16 plus 9 and a squared plus a squared equal a4.
A squared plus a squared, you sure?
Yes, sir.
You sure about that one?
Yes, sir.
Okay. Anyone else would like to chime in right now?
Hold on.
Mhm.
Who was that again? Who was that? Shay
I think that's, is it Shay? Was it Shay?
or Tatiana? Tashel.
Oh,
Tashel, when sir was showing us down here with the 3a multiplied by 3a. It was multiply or add that sir used. He multiplied, he didn't add. So he told you the law of indices applies when we are multiplying. So since we have 9a squared plus 16a squared, the law doesn't apply in the same way when we're adding as what sir had said. So we can't just add the 2 on each of those variables, the square, the exponents. We can't just add the 2 to the 2 and get 4.
Miss.
So, yes.
So you're saying that if I was multiplying it, it would be so for example, if it was so 9a squared plus 16a, it's a squared. If it was 9a squared times 16a squared, it would be the number a4.
Yes, perfect.
If you're adding it,
yes, you'd get the number 9 times 16, and then you'd get a4, a to the 4th power. Yes.
Okay.
But remember that we're adding now, so we need to find something that we call I want to say it, but I don't actually.
Common, something common.
Yes, something common, right? So if you notice, both of these terms have a squared on them, right? Everyone has seen that?
Yes, sir.
Right. So it's basically saying, okay, even though I should use this analogy.
How many a squares we have first? How many a squares we have first?
For this one.
Huh?
How many do we have over here?
1.
Look how much, what number is in front of the first a square?
9.
9a squared.
So that's the coefficient of it. That's 9. We have 9 of them. How much we have in the other section? Or how much are we adding then? 16. So if you have 9a squares and 16a squares, how much do you have in? How many do you have in total? Is how many or how much? I don't know.
Troy said 25.
All right.
And that would be 25a squared. So let me just delete that because I'm going to annotate. Let me get this off. Okay. So that's 25a squared. And
Does
that's
that make
equal
sense to
to,
you guys?
Yes.
okay.
If it doesn't
Oh,
make sense, tell us.
and Troy,
Means
how
that-
did you get 625 when you finished?
Good job, Troy. Don't know
So
how
how
you
did
get
he
it.
get six? How did he get 625?
Don't know what he did.
Troy, you want to tell us or explain to us how you got 625?
I was
Oh,
talking
you
about,
multiplied. Why did you multiply?
I was talking about the 25, Troy.
No, Troy.
Why did you multiply? Troy?
Oh,
So what he did, yes. So because it
squared
says a
25.
squared.
he squared it, yeah.
Yes.
Yeah.
Because let me get this thing. 25a squared. It only means that this is a coefficient and
By
only
itself.
the a is squared in a sense, right?
Mhm.
Yeah, so
So
only
you
the
can't put a square, a random square, you can't put square above it like that. That wouldn't lead you to the answer, right? So it's
Mhm.
just 25. So the number or the coefficient in front of the a squared is 25. And it's being multiplied. Yes. And it's being multiplied by the a squared. So what's
Yes.
the opposite of multiplication?
Division.
Division. So would I divide one side or divide both sides? And what do I divide them by?
25.
Why divide by 25?
Why
Why can't divide
25?
by 5?
No,
Because we're trying to get A by itself.
Excellent. Great job. We want to get rid of that 25 from over there. We want to make A the subject.
So now we're gonna do some more maths by dividing both sides, right? So we divided both sides by 25. So now 25 into 25 goes one time, likewise with numerator. And then we say,
Before you go on, sir, 1 minute. So all we're doing, there have been several operations that has happened to A. So we're just undoing what has happened to A. A has been multiplied by 25. So we're going to divide by 25. And then you will also see what else is happening to A. What else is happening to A, people? A is being what? What is that?
Squared.
Squared. What is the opposite of squared?
Square.
Oh my gosh, you're
yeah.
so awesome.
A little bit more. What about if I had a cube? How would I get rid of something looking like this?
How are you
Just,
doing?
I'm just.
It's fine.
A cube. How would I get rid of the cube? What would I do to the cube?
You
I
guys
don't
know
want
this.
the cube to be there again. What would I do? Anyone?
the
Come
cube.
on.
My name Cube.
Huh?
Yes. She said it.
What is it?
My name Cube. Root.
Yes.
Oh, cubic root. We put the
Yes.
3 inside of the square root. The root sign,
That's
sorry, not the
fine.
square root. So
Right.
notice, you see the difference? So most times you actually should put a 2 right here to
Right,
indicate
but-
the square root, right? So this would be the cubic root. Whatever value is inside the root, that's what we say, and that's what we use. So that's that. So that's how you'd have gotten rid of that one.
The cube. Good. So we're undoing the operation that has been done to the variable. So divide by 25 because it was multiplied by 25.
Oh, my
Although
bad.
strictly speaking, Mrs. Lodgefendon, they first squared the A, then they multiplied by 25. So we're doing it in the reverse. The
Right,
last
so we
thing
do it-
done to the A was that it was multiplied by 25. The
Even
first
better.
thing done to it was that it was squared. So we're starting with the last one and then going backwards. So we divide by the 25 and now we have to find the root. But your people have been blowing up the chat with their 3 units long time. 3 units laugh out loud. But we're not paying them no mind.
Not paying to shall no mind either. David, I see your 3 units, and he made sure he put units. He corrected Troy. Oh, all right, good. You guys are having fun. I'm glad. So 5 divided 25 a squared divided by 25, leaving us with a squared. 225 divided by 25, giving us a value of 9. And then you would do what? Find the square root of both sides. Great.
And what would the value of A is actually 3. Not
3 what, sir? 3?
yeah, 3.
Oh,
3,
it's
3,
not 3 units. It's 3. The
Okay.
entire thing will be the units when you calculate the 3.
So you would have 4 multiplied by 3, and you get 12 units on this side. 3
Yes.
multiplied by 3, and you get 9 units on the base. Okay.
David and Tisha, not Tisha. David, you realize why it's not units?
Oh, why? I don't think. Repeat?
Because it's not the length.
Okay.
We just found the variable. The
just
unknown.
All right.
So
Oh my
remember,
God.
sorry.
It makes sense. Yeah.
So remember now, this would have units beside it.
Exactly. As I told
This
you.
would have units beside it,
Right.
right?
Yes, sir.
So if we actually had, let me not say that. Yeah. So I have the units beside it. So something like this, right? And then the value of A is 3. 3 times 3 gives you 12 units right here. And then 4 times 3 is 12 units.
Right.
Sorry, 9. I literally can't count.
Oh, sure.
I was always on the ball with 12 units. Oh, yeah, but you get the gist. All right. Okay, I'm gonna delete this before Mrs. Lodge Fenton does
So
the
you
other
see, guys,
last
how the concept of trigonometry, Pythagoras theorem, can be used in other questions. So you have to understand the concept, and it can be tied with algebra. So if you don't understand the relationship that exists with all those 3 sides, although you're very good at algebra, you would have not gotten the first part correct, which would have then kind of prevent you from getting a question that you should be very good at, an algebraic question. See that?
Yes, miss.
Right. So that's it, because all 3 sides, values were given for all 3
on
sides
to the last question.
for the afternoon.
Yeah. This will require your undivided attention for this one. Okay, everyone? So the rain is falling on my side, so I have to, yeah.
Right here, we're hearing you. Ah, look at that. Starts talking like you guys don't know how to do this. This can be done. Right, guys?
Yes, miss. Sure.
Sure, of course. What are we asked to find here?
X.
X.
X, right.
Oh. We can find X.
And notice the 2DP, don't forget that.
Yes,
Yeah. Well, how we find X? What we can do to find X?
All right. So, yeah. All right. So I think to find X first, I think we find the X at the 3X first, right?
Okay.
Yeah, and it is the same formula. So
They're going to use. You're going to find 3X before you find X.
no. Oh my. Never mind.
Oh. But go ahead. Go with it and see where it goes, David. Is that David or Troy? David?
Yes, David.
It's not silly, David. You are on the right track, but I want you to realize what's going to happen. So write it down in your book and we'll talk us through it.
Sure.
So you're working from the 3X side. All right. How are you going to run with this?
Because I'm trying to find the opposite side.
Ooh. All right, so guess what I want you to do? I want you to try and start with whatever we've been telling you so far. Write your equation down. A squared plus B squared equals C squared, where C is your hypotenuse. First thing. Then I want you to substitute the values for triangle S.
Yes, miss. Right. Yeah, that makes sense.
Mhm.
So it would be a squared plus 3x squared equals C, equals, well, 27 squared, because because the answer for the hypotenuse is 27, that would be the square roots of C squared, right? Yeah. So I put it back to 27 squared, right? All right, and then I'll start working from here. So 3x squared, that would be 9x squared, a squared plus 9x squared equals what is 27 squared? I'll come in. All right, so that's 729, right? So now I have a squared plus 9x squared equals 729. All right. So what do I do from here?
Mr. Lee, to help David with this one?
Oh, yes. Okay. If you can hear me, you can hear me. All right. All right. So for this one of the things we must note is that the right angles, you see the right angle right here and over here, right? Everyone is seeing that? What would this side be called? As in, would it be called, what would it be called?
Hypotenuse.
Hypotenuse. And what would this side be called?
Hypotenuse.
Hypotenuse.
So notice for the two triangles, the two smaller triangles inside the larger one, you have the hypotenuse being given on both sides, right?
Yes,
For
sir.
both triangles, right? Okay?
Yes, sir. Yes, sir.
And, okay, and you also have one each of the shorter sides. So you have one shorter side on triangle S, which is 3x, and then the other on triangle D, which is 3, right? So notice that both of them are actually somewhat at the same place. They are at the base of each of the triangles. And the orientations, even though it's a bit different, but they are at the base of the triangle, right? So we need to classify those two figures as either A or B, and we need to be consistent about it. So we can't have 3x being A and then 3 for the next triangle being B. It must be the same letter in order to proceed to find X and onwards, right? So in other words, in a nutshell, I'm actually going to find this first, this little side right here. And then I'll be able to find the value of X. Well, I would say simultaneously, somewhat simultaneously.
Oh, so, okay, simultaneous equation?
Somewhat.
Okay.
All right, everyone is on the same wavelength. That's physics. Everyone is on the same, okay. Everyone?
We're listening attentively.
Okay. So now, so remember that we have a triangle X, we have the hypotenuse, and we have a shorter side. For triangle D, we have the hypotenuse on a shorter side, right?
Mm-hmm.
All right, cool. So let me just, I shouldn't erase it. Let me not erase it.
It's fine. You can leave it.
Okay. I'm just going to write about the hypotenuse right here.
Mm-hmm.
All right, let's continue. So we're going to look at triangle S and triangle D somewhat separately. So let's begin. All right, so this is actually triangle using triangle S, right? So we go back to the original thing, which is says that the Pythagoras theorem is the sum of the two squares is equal to the hypotenuse squared, right? So for C, sorry. So over here, this is our hypotenuse that we'll use for C for triangle S. And then remember I said that we need to use the same, whether we use A, we need to use A consistently for right here and right here, or we use B and B. Doesn't matter which one you use, you'll get by the same answer. But you must not interchange them, meaning you must not have B for A for 3x, and over here you have A. You can't work it. It can't be done doing that, right? Because that would lead to some form of misconception, if you want to call it that.
Mm-hmm.
So let me just get this out of the way. So remember, whatever 3x is, whether it's A or B, it must be the same for the number 3. It should be A or B, whichever one you choose. But I actually chose A. Let me get that over. So I actually chose 3x to be A for triangle S. And then when you work out triangle D, I'm going to use A as my 3, right? So I'm actually finding B, and then I continue afterwards. Okay, what you want me to go over, Tasha?
So when I look on it, I don't know what to look for. No, I'm gonna feel.
What do you mean? Could you repeat?
So when I look on it, I don't know what to do. I split them.
No, you won't split them. You keep them as it is. But I'm saying to you, you see the arrows going up and down? Well, the 2 arrows going left and right?
Yes, sir.
So we label that as our hypotenuse, right?
Yes, sir.
Now I'm saying the base of the triangle, the base of the 2 smaller triangles, one of them is 3x on the left, triangle S, and then triangle D, you have 3, right?
Yes, sir.
So that's one of the shorter sides, right? Okay?
Yeah, it was like,
That's one of the shorter sides. So, and it's at the base. So they must be the same letter, meaning it's either it is A is 3x, and A is 3 for this triangle. For triangle D, A is 3. For triangle S, A is 3x, right? Right, Tasha?
Okay. Animation.
You following now?
Yeah, bring up some more animation so we can probably follow a little bit more.
Yeah. All right. So I use my A as 3x. And what is unresolved? What do I need to find? For that one is B squared, right? Or B, the letter B, sorry. Right?
Right. Side B.
We have the hypotenuse, 27 squared. And we have our A value, which would be 3x, right? So let's go further. And then we expand and, well, expand. So 3x squared is 9x squared. Everyone understands that so far? Yes or no?
yes, sir.
Oh, I think, oh, my battery is running low. Sorry. It was about to turn off. All right. Yeah, it was about to turn off. So now we have 9x squared added to B squared is equal to 729, right? So the unknown right there is B squared, right?
Right.
So I remember, well, you should have done transposition already, maybe in 4th form, I hope. So you want to get rid of, not really get rid of, but you want to You don't want that 9x squared to be right there anymore.
Okay.
You want just b squared on one side, right?
Right.
So what do I need to do in order to...
You're going to carry over.
Right.
Okay, you're gonna subtract 9x squared on both sides, right?
Cool. Yeah, yes, sir.
Right. Which is that, and then simplify it a bit, and then we get that equation. So that's our equation 1, right?
That must have.
Okay, sorry.
Yeah, I said you're supposed to carry it over.
Yeah, thanks, Tatiana. Okay, so this is for triangle S, right? And now I'm gonna do the same thing for triangle D.
Right.
And now remember what I had highlighted earlier. I use my A value as 3x because both of those, the 3x and the 3, are at the base of the triangle. So they must be the same.
The orientation. We're keeping the orientation.
Yes. So we're keeping the orientation. So it must be the same letter.
Base, and that vertical line in the middle is going to be B for both triangles.
All right. So everyone is okay with that? That's my first equation, you know. I'm going to use it back. So pay attention to this one. The other way was a bit more complex and rushed. So this is a simpler way. Even though it's longer, it's appropriate. All right. Now I'm going to use triangle D. So triangle D, we have our hypotenuse. Write back our equation. A squared is A squared plus B squared is equal to C squared. The sum of the square of the
two shorter sides
is equal to C squared and C being our hypotenuse. And we have our hypotenuse for triangle D. Make sure you're looking at that triangle D, the smaller triangle. And you have the hypotenuse as X, right?
Right.
So what would my value of 3 be for that triangle? Would it be A or would it be B? Which one?
Sure.
Which one would it be? Huh?
Oh, you know, just so we use it for A.
Yeah, I'm just asking, I'm just clarifying.
Okay.
Yeah. All right, cool. So let me get this out of the way. All right. So the same thing applies, right?
Yeah. What do you want to go over?
Oh, I think, I said it, I did it already with everyone. Yeah.
Okay.
I was, late-ish. All right. So now we have our A value for triangle D to be 3, right? Then we do the same thing. 3 squared, one of the shorter sides, add it to another shorter side, which we don't know as yet, and it's equal to X squared. The C value is now X because X is our hypotenuse, right?
Right.
Sure. All right. Then we just square that number. Which we
simplify as best
possible. Square it and then we transpose and then onwards, right? So we get 9 added to B squared is equal to X squared. And then we don't want the 9 to be on the left side anymore.
We want to transpose for B squared.
And notice now we have B squared is equal to X squared minus 9. That's my equation 2, right? So both equations, what do you notice about both equations? Both of them have weight, but both of them have what in common? What do they have in common? What do they have in common? Huh?
B squared, sir.
B squared.
B squared.
So now I can actually say B squared is equal to B squared, right? Even though it might not sound like it makes logical sense, but
so what we're saying, we can express square. So the middle, that vertical line represents the same length. And we now have 2 expressions to represent that length. Because, well, the square of that length, we should say, the square of the length. Because we have B squared, we have an expression for B squared. So we have one expression over here saying 729 subtract 9x squared. That represents B squared. Then the other, we have the same B squared, because we made sure we noted that is the same length we're looking at, can also be expressed as X squared minus 9. What do we do, sir?
All right. So equation 1 should be equal to equation 2. In other words, B squared is equal to B squared. B has to be the same length, right? So equation 1, could you repeat that one?
Yes, so are you saying like for both triangles? Well, obviously, yeah, of course, B squared is going to be the same thing.
It's the same on both sides, right? So it's like that great divide that parts them, and it's the same on this side, same on that side, right? Like somewhat like a mirror line.
Right.
All right. So basically, as David just pointed out, and Mr. Limi, that length that we're looking at, b squared, we can express it in terms of triangle D, and we can express it in terms of triangle S. But we know, because we can look at it and see that I same length we're talking about. It's like you have a wall in between two houses. I same wall. It's my wall sometime, and it's your wall sometime. But
Our
it's
wall. It's our wall.
It's our wall. Okay, so that line in the middle belongs to both triangles, but it is the same measure in length.
All right, so that's how we have b squared equal b squared. So the equation 1, whatever b squared is, which is 729 minus 9x squared. We're going to write that under the left, the b squared under the left over here.
Yeah, go ahead, animate it, animate it.
Yeah. So you now see that we somewhat got rid of the b value, right? And now we can actually solve for x.
Sorry, let's use some other terms. So now we have an equation with only one unknown.
Yeah.
We can work this out.
All right. So you group like terms. You group all the x squares on one side, and you group all the constants on the other side. Constants, they don't have any variables attached to them, right?
Right.
729 is a constant, and -9 is a constant, right? Everyone is okay so far?
Right.
David?
Oh, yes, sir. Sure.
Now I have a little thing that I would do. I would keep my largest whole number constant positive.
Yes.
So my 29, I am going to keep it right there, and I am going to undo the -9 there, or sorry, undo the subtraction of the 9 and add it. The 9 by itself, the 9 constants. I'm going to take that over there. Oh, you're just doing that. Okay.
Yes.
So
what
if you group them?
Could you repeat?
I'm asking if you wouldn't group them, group the like terms.
Yeah, you're gonna group them now.
That's what we're doing now.
Okay.
So this -9x squared and -9x squared, which give us 0, right?
Positive and negative. Positive 9,
Correct.
right.
Yeah. And then we have x squared added to 9x squared. And remember, what is in front of the x squared, in other words, the coefficient, is actually 1. So that's 1 added to 9, as we alluded to earlier, which would be 10, right? So let me get that next part rolling. So now you see that we're just left back with 729 on the left side of the equation, and that's equal to 10x squared minus 9, right? All right. So this one.
Okay.
Yes, Carl, I see that one. All right.
So
yeah.
So we have 729 equal 10x squared, subtract 9.
Yeah.
What's the opposite of subtracting 9 from that variable over there? Opposite would be what? Adding 9.
Right.
Add 9 to both.
So that's what I'm gonna do right now. Then you see that, bam, 729 added to 9. All of the constants are on one side, and all of the unknowns are on the other side, right? Which gives us this one. 738 is equal to 10x squared. Now, that's somewhat almost the same thing or similar thing that we did earlier, right? So what should I do now? Before I actually find the value of x squared, then find the value of x. What computation should I do? Should I add, subtract, divide, or multiply? And what do I add, subtract, multiply, or divide by?
You divide.
All right, divide. Divide by what though?
10.
10. Why do we divide by 10?
Well, because I mean you have 10x squared, so you divide.
And the unknown is actually x squared, and then to get that x squared, we need x and so on and so forth. So that's how we divide by 10. So we divide both sides by 10 because we have an equation. Everyone understand so far? No
So
objection?
David, is it? Yes, thank you, David. It wasn't 90.
Oh, yes, okay. So let me continue. So we divide those numbers, 10 into 738, and that goes 73.8, and that's equal to x squared, and that's back to our layman's term.
Sir, I sure we said 2 decimal place.
Oh, did we? We're not finished?
Oh, yeah,
Oh,
yeah,
it's true.
yeah,
It's true.
We're not
Oops.
finished.
You're going to square root.
Good,
Oh, thank
Tatiana.
you.
So we're going to square it both sides because we want to get rid of that. We say we want to get rid of that squared that is somewhat attached to that x squared, right?
So it's not X you want to find, sir?
Yeah, but you know, layman's term.
Okay.
So we get the square root of 73.8 is equal to the square root of x squared.
So hold on, don't tell him.
Yeah,
David,
they'll
what's the
work that
answer?
out.
David, what is the answer? Estimate it.
8.5. 9.
Make sure it's not the exact answer, no miss.
Never mind.
Okay.
Estimate.
I think it would be between 8 and 9.
Okay, because 8 is what? 8 is what? 68?
4 and
4
9
is 99. 81. All right. So it would be, I mean, she told us a while ago, but yeah.
Okay. Did anyone get the answer for that one to 2 decimal place?
Yeah, 8.59.
Let's hope that's what I have. Because I think I never even remembered about the 2 decimal place. But let's see if I'm getting your what? How did I get that?
I can't
That's
see.
wrong. Yeah, I need to change that. So that needs to be changed. And what was
You
the
can
answer?
write. You can write it. You can
Yeah, I
get your
can.
pen and
I
write the
can.
correct answer.
I can.
Put an X beside that answer.
And cross it out. Cross out
Put
that
an
one.
X beside that answer.
Okay, what's the answer?
8.5 units.
8
It's
points.
good that we know our estimate. We had an
5.9.
estimate to
Good.
say it would have been between 8 and
8
9.
points.
So when we see that come up, we know
Exactly.
there's an error.
You see how important that is?
8.59.
Yeah, 5.9. Units? Okay, the units is there. All right, we figured it.
Yeah, I can put. Yeah. Remember, I find in value of x. So yeah.
Oh, yes, it's true.
Oh,
You can put units.
so,
Yeah, the
yeah.
final answer.
The units is there.
Right. So, sir, so the 8.59 is also the variable at 3x. And
Oh, look at that. No. Go
is
ahead,
it?
David.
Repeat that one.
Yes, it is.
Yes, so
Yes,
the
it is.
8.59 is both the variable for 3x and the hypotenuse x.
Yes.
Oh, wow. That is
Oh, wow.
great.
I'm also checking something.
Because I was wondering for units, and I was like, if you find the variable.
And even if I calculated 3 times the value of x, which is 8.59, I get 25.77, right? And
Which
that
is
is
still
still
less than
smaller than the
27.
triangle S hypotenuse, which is 27. And I do the same thing for the other side, right?
Wow. Yes,
Yes.
sir.
Beautiful.
All right, so b squared or hold on.
I mean, we found the value of x. That's what we were trying to find. If you want to find x, then
Sorry.
to find x, you need to square root that. So that's how I got that the 2.72. I found b. I actually found the value of b.
B, okay. That's
which
awesome.
was, yeah, 2.72 or something of that nature. And it's not, no, that's not a wrap. That's not a wrap. That's not a wrap. Do I need to go over anything before we continue to the exam tips? Oh, the other way was, as Miss Harris highlighted to me, that way was.
You want me to share it? I don't think it was so
can.
complex, sir. If you want,
it seemed complex to me when I was in. I was like, let me do
right,
that for you.
So what if we remember that the two sides, if they share a side, what do you know about the length of the two sides? It would be the same, wouldn't it? Talk to me now. It's only let's talk.
Yes,
If
miss.
if the length of this, if the same length is for, if that length is for both triangles, somebody write in the chat for me, how would it use Pythagoras' theorem to using triangle S? How would you represent the length of that unknown side? Using triangle S, how would you represent it? Using your Pythagoras' theorem. How would you write it? Type it in the chat, all right, or say it, whichever one is easier.
Mr. Can I repeat me so did hear?
How would you represent that unknown side, that circle called B, the one that we're calling B? That side that you call B, how would you represent B using triangle? Sir, could you just separate the two triangles for me, please?
The vertical line.
The vertical line, yes, thank you, miss. That vertical line, just draw the two separate triangles for them for me, please. So triangle S on one side. It's usually useful to separate the triangles so you can kind of see it a little better. Right? Both of them have the same length, don't they?
Yes, they do.
Right. So how would you write, based on what we learned from our scenarios, would you be using scenario 1 or scenario 2? Are you finding a hypotenuse or a length, a leg?
Good question.
Hello? Leg.
Leg, good. So how do you find a leg using Pythagoras' theorem?
Miss, the one of the legs them that they have is subtracted from the hypotenuse.
Right. So tell sir what he should write. Go ahead, Tashel.
I'm thinking.
All right.
What's
What is the hypotenuse? Based on the theorem, what would you say?
The hypotenuse I mean 27 and x.
Right, but we're using one triangle at a time.
So using triangle S.
So we're starting with triangle S. What would you say for the length of that leg? Anybody can come in, Tashel, anybody who has been participating, or even somebody who
So how can we write an expression? I'm just going to use that to represent. Tell me how you'd find the missing side. What would you do? You just said it. Hypotenuse, take away the other leg. So tell me exactly what would you do? The square of the hypotenuse, take away the square of the shorter leg. Just give me the values there now. Give Miss Harris the values.
For triangle S.
1.23.
No, don't find the
value. What
just
is the
use your Pythagoras' theorem. Sir, do it for triangle S for them and allow them to do triangle D, since we're against the clock.
What is the value for the hypotenuse? 27. So it's the square of 27. Subtract. Sorry, you know, see the subtraction sign you put already?
I'm going to use the equal sign.
Wait. I was doing the two at the same time.
Yes, Mr.
Yes, you were.
Okay. Right, it's 3x.
Right.
Oh, that's subtraction sign.
Yeah, that's subtraction sign. That one.
I never even realized.
So change it to your equal sign then, sir.
So guys, it is the square of the hypotenuse, tenues, subtracting the square of the other short side would give you the value of that missing side.
What about on the other side now?
So now do it
for the other triangle.
Finish one.
Oh.
No, we don't want to.
No, we're not ready to finish it yet.
Oh,
we're using the fact that the two sides are the same. The side is the same for both.
David?
Hello.
What's the hypotenuse on triangle D?
On triangle D, that is X.
Good. So what is the square of X?
The square of X is 73.8.
Remember, we started the question from scratch. Don't know anything yet.
X squared minus.
Right.
It's just X squared.
X squared, right?
Yes. What is the square of 3?
The square of 3 is 9.
Right. Okay. So good. So we just want to write 3 squared there. So you can simplify. So what I'm down there, sir?
Well, I'm actually solving it. Why am I solving? Yeah, I'm actually solving it.
Then I go on left way.
I'm gonna get about to say almost, you know.
You are.
Yeah.
So what
27 times 27 is 729.
Mm-hmm.
Yeah, which is this? Do I have to continue?
Right, and so you do have to continue. So we're coming to that line that Sir
Right
had
there.
initially.
Yes.
But you'd end up there faster.
Right, because we're using the fact that the two things are equal. The fact that the two
Yes.
that length is shared. We can use Pythagoras' theorem for both lengths and equate, because in maths, when two things have the same represent the same quantity, we can we can equate them.
Right.
Yes, lovely, lovely, lovely. You see that we can work in two different ways and get the same
That's
answer?
awesome. So instead of finding equation 1 and equation 2, Carol already, Miss Harris already knew that b squared is the same on both triangles. So you can just equate the values, the expression for b squared right away.
Yes.
So you create, and this often happens in a question in CXC. You know, they may say to you, given that so and so is so, and you form an expression, and then they go on to say the length of the length of a square is that, and then they go on to say that the area of the thing is that square meters, and then they expect you to form an equation because you formed an expression. Then they give you a specific value for that expression, and then they ask you to solve it. So it's the same concept. You're equating quantities because you know they share the common value. Just thought I would throw that in for good measure. Hope it helped.
I think it did. Right, David? Shay? Michelle?
Raise your hand.
Right.
Good.
Mrs. Williams, Faithlyn Williams, I just sent the email to you so you can send it in the chat for them.
Noted. Thank you.
You're welcome.
Michelle, go ahead.
So, Miss, what is the answer for the line?
Oh, that's so sweet. So, let me take that. David wants to know how he stays in contact with us. So, you know, he sent off his email to us.
All right. Okay. We will keep in touch with David.
Most definitely.
We will be in touch, David. Any one of us, there are about 8 of us, someone will contact you within a short time. Or I don't know if someone wants to send your email privately to David right now. Any takers?
I'm going to
Can
send
we go
it.
ahead and do the exam tips?
Yes, the exam tips. I was right about to say it. Yeah.
All right. I'm just going to send it out there to the
Yeah.
group because okay, so you see what? So everybody.
The answer for the middle line is a triangle.
Go ahead with the exam tips.
Oh, the exam tips. Just relax. Literally, just relax. You're gonna read and reread the question carefully. E means you examine every answer before choosing one. L, look for information in the tables and the charts, tables, graphs, and charts. A, always check your work. I mean, always check over. And then X out answers you know are incorrect when you have multiple choice. So that's really it. Just relax when you're doing the exam. And the next one, the final one, I think. Okay, the final one. So first one, reading from the left, going to my right. So underline the important words, the most operative words, the words that are quite important to you. In solving the problem. Restate the question in your own words, form an opinion of your own. And then the third step, reread the test item, including all answer choices. Then the fourth step, analyze and eliminate answer choices. Answers that you think would never be an answer, especially when you're doing multiple choice. And the out of ordinary answers, that's step 4. Step 5, check your answer in the context of the problem. See if it makes sense, if it applies to whatever the question is that you just answered. That's really it. Step 5 steps. And always relax when you're doing an exam. Really, just relax. It's gonna be fine, I think. Okay.
Did you just I think?
Huh?
Did you just I think? So as Sarah said, guys, it's very important that you do not become flustered or you minimize the anxiety that you have in an exam. So you have to prepare. Watch the videos that you can, read, study, have your time where you are familiarized with the concepts in math in any exam that you're doing, so that when you go into the exam, you are equipped. And once you're equipped, relax. Well, even if you're not relax.
Go ahead. Go ahead.
Hazel.
Go ahead.
I was saying, even if you're not equipped, just relax. Because what's anxiety going to do for you? Nothing. So relax and try your best. That's all that we can ask of you. Okay?
All right. So as we close off, we have put in the chat the link to the evaluation. Please, we'd like to hear from you. Let us know what you think of the session. We have also included in the chat the links to the YouTube channel for the three presentations this week: coordinate geometry, the statistics from yesterday and today's work, as well as the tutorial for each day. You can go through in your own time and look at that. The exam tips, we ask that you learn what the paper should look like. You know that there's a paper 1 and a paper 2, and you're not allowed a calculator in the paper 1. Read for special instructions and so on. But generally, make sure you are ready in terms of your equipment. You must know which day you can take a calculator, which day you don't take a calculator. Make use of the graph leaves. Use a second method. Use estimation to decide how you answer your questions. All right. We would like to thank you for joining us. We will have some extra presentations maybe later on. So look out for them. You're 3 weeks from exam. Look out for and ask your teacher about facilities for the links to our presentations if we have any further on. That's it for me now. Is there anything else anyone would like to add? Any questions?
Oh yes, Miss. I
Go
think I just say we should actually, I think it's safe to know how to find the square root of numbers without a calculator. Because I mean,
Yes.
what if a calculator just decides to break or something like that?
Okay, you must be able to estimate. All right. Got
Yes.
you. I don't know who that was, but thank you. All right, so that's it from us. Remember to do the evaluation for us. Mr. Lini, can you end the YouTube for us, please?
I will right now.
We are still taking your
just a
questions.
second,
Any
Mr.
other
Lini.
questions, comments?
Question, just a thought. Mrs. Darby, just a thought. Is it possible for us to place the links to the tutorials in the YouTube channel? Is that possible?
Yeah.